The world spent years treating fifth-generation fighters as the final word in air dominance. Then the F-47 silhouette appeared in classified test corridors, and everything changed. For the first time, a new system didn't challenge fifth gen. It stepped past it entirely. And the question shifted from capability to survival. Analysts started asking whether fifth gen can survive a fight against something built on an entirely different model of warfare. Because if the reports are accurate, the old assumptions about air superiority no longer hold. The world assumed the F-47 was America's reaction to China's sudden surge. The J-36, the J-50, and the sixth-generation prototypes Beijing unveiled to shock the global defense community. Analysts treated it as a straightforward arms race and a response to foreign competition finally catching up. But that assumption missed the truth entirely. The F-47 wasn't built because another nation advanced. It was built because the United States had already moved on to the next era long before anyone else realized a race had started. The F-47's roots trace back to DARPA's Covert Aerospace Initiative in the mid-2000s. It was a program so compartmentalized that even members inside the Pentagon only knew it existed and not what it was building. Boeing wasn't designing a prototype. It was refining a machine that had been shaped in simulator labs and classified wind tunnels long before anyone outside noticed the shifting shadows over California test ranges. While the world was celebrating the arrival of fifth-generation fighters as the pinnacle of aviation, the F-47 was in the desert, learning how to rewrite the rules. Based on how sixth-generation systems process the battle space, engineers warned early that a fifth-gen jet might be outmaneuvered electronically before its pilot even understood the threat. We'll return to that moment later. But first, let's discuss why fifth gen was never going to hold the crown forever. Fifth-generation fighters changed the battlefield. Stealth reshaped radar equations, and sensor fusion created pilots who could see through their own aircraft. The data-sharing networks turned small formations into coordinated mines. But fifth gen was always walking toward a wall, even if no one wanted to admit it. What contributed to these limitations? The first was its thermal limits. Once an F-22 or F-35 starts pushing its engines to extreme supercruise or high-energy maneuvers, heat spikes give away position to infrared sensors. The second is stealth saturation. Open-source analysis shows radar cross-section improvements reached diminishing returns. The truth is, shaping alone can only suppress so much energy. Then there's computation that no one can engineer around. Fifth-generation fighters can interpret what's happening around them, but a sixth-generation system has to predict the battle space before threats even unfold. Add to that the problem of range. Indo-Pacific distances simply overwhelm anything limited to a 700 to 800 nautical mile combat radius, and the picture gets clearer. Finally comes the human limit. Even with the most advanced cockpit, a pilot can only absorb so much data, electronic noise, as well as tactical pressure in a single moment. And the battles of the future demand more than any human can process alone. Engineers realized they couldn't squeeze more power out of the fifth-gen template without breaking it. So the F-47 wasn't born from upgrades. It was born from abandoning the idea that a fighter is just a fighter. There's one capability it unlocked that a fifth-generation jet simply cannot match. We'll see it when we reach the sensor section. When the first F-47 silhouette surfaced online, viewers noticed something weird. It didn't look like the sleek arrow of an F-22 or the shark-like profile of an F-35. It was angular in places that should have been smooth, curved where traditional fighters are sharp, a wingspan wider than expected, no edges that reflected classic fighter lineage. The entire airframe seemed sculpted for an environment the public had never seen fighters operate in, and that's the point. According to open-source descriptions of 6th-generation goals, every external feature of the F-47 is designed for broadband stealth. Its shape suppresses visibility across radar, infrared, acoustic, and even certain passive tracking sensors simultaneously. 5th-generation stealth aimed to minimize visibility to specific radar frequencies. 6th-generation stealth aims to reduce signatures across multiple spectra simultaneously. The F-47 manipulates the very way sensors perceive the air around it. Then there's the composite skin embedded with distributed sensors. They map airflow, heat signatures, and electromagnetic energy in real time. The F-47 senses the battlefield as well as itself and adapts to the surrounding environment second by second. That capability becomes crucial when we get to the sensor battle that 5th Gen simply cannot win, no matter how many upgrades they receive. Here's something to think about. With modern fighters shaped as much for sensors as for aerodynamics, which matters more in the next war, the airframe you build or the data the airframe can protect? Drop your insights in the comments below, and we'll get back to this at the end of the video. If there is one component that separates the F-47 from every 5th Gen fighter before it, it's the engine. A notional adaptive cycle power plant built around the same principles driving current 6th generation propulsion research. 5th generation engines like the Pratt & Whitney F119, F22, and F135, F35 are miracles of engineering. But they're locked into fixed operating modes. Either they deliver huge thrust at the cost of fuel or efficiency at the cost of power. The F-47's engine doesn't accept that trade-off. Their adaptive cycle architecture theoretically allows internal airflow pathways to reconfigure mid-flight. At one moment, it's configured like a high-bypass engine for long-range efficiency, and the next, it behaves like a low-bypass fighter engine capable of explosive acceleration. In concept, such an engine could supercruise without afterburners, generate significant electrical power for next-generation weapons, and even maintain a controlled thermal profile to reduce infrared visibility. But what's the biggest advantage over 5th Gen? It's the range. Rumor inside the testing community about adaptive cycle engines suggests that projected combat radii in Indo-Pacific scenarios could dramatically exceed current 5th Gen limits. Some analysts even speculate that a 6th generation platform paired with autonomous wingmen could operate across oceanic distances without relying heavily on vulnerable tankers. That moment became the reason 5th Gen physics stopped mattering. They simply couldn't match what an adaptive engine could do when you asked it to operate beyond the edge of the map. Here's the part no one in the 5th Gen world wants to talk about: the sensor revolution. In 5th Gen, sensor fusion means the aircraft collects data, merges it, and presents it cleanly to the pilot. It's a powerful upgrade over old Gen cockpits where pilots suffered from information overload. But according to open discussions around 6th generation requirements, a next-gen system is expected to go further by interpreting patterns, predicting threat trajectories, and initiating responses at machine speed. Analysts describe future platforms using technologies such as distributed aperture sensors, secure high-bandwidth data links, multi-band radar arrays, passive optical tracking, synthetic vision overlays, and onboard processors designed to run predictive models of the battle space. 5th Gen fighters rely on human reflex. The F-47 leans into machine speed reaction time. And this is where the comparison becomes dramatic. Modeling work done by defense analysts shows that in theoretical simulations, an aircraft built around predictive processing could gain a timing advantage long before a human pilot recognizes a threat cue. In other words, a 5th Gen jet is outmatched and out-timed. That's the difference this new sensor architecture introduces, and why the next spec matters even more. This is where the fight becomes unfair. For years, the Air Force hinted that the next generation of fighters wouldn't operate alone. Instead, they're expected to coordinate with autonomous teammates known as CCAs, Collaborative Combat Aircraft. Wingmen without cockpits, shot absorbers, decoys, missile trucks, EW platforms, recon probes, strike assets, all controlled by the fighter at the center. But here's the catch: 5th-gen fighters were not built to be command nodes. Their data pipelines can't handle multiple autonomous teammates. Their cockpits weren't designed for that workload. Their onboard computers weren't built to coordinate distributed assets. On the other hand, the F-47 was designed for exactly that. Picture this scenario. An F-22 detects 2 enemy aircraft. A next-generation platform detects many more because, if you're wondering why, it's because part of its situational awareness comes from cooperating drones, not just its own sensors. An F-35 launches 4 missiles. The F-47 launches none because its accompanying CCAs could release the weapons while the crewed jet preserves its stealth. A hostile radar locks onto a formation. An electronic warfare drone could alter the return, creating false tracks and confusing the emitter. This isn't a fighter anymore. It becomes a networked combat system. And the moment a 5th-gen fighter tries to fight the F-47, it's not fighting one threat. It's fighting an entire coordinated system, each piece operating at machine speed. That's the moment analysts realized the question wasn't whether a 5th-generation fighter beat an F-47, but rather, can a 5th-generation fighter survive long enough to disengage from one? If you're still here and enjoying this breakdown of the F-47, please like this video and subscribe to the channel. We always appreciate the support from you guys. If there's one theater that exposes the aging skeleton of 5th-generation aircraft, it's the Pacific. The distances are brutal. The bases are vulnerable. And if you think about the tanker fleet, the lifeline of 5th-gen jets remains some of the most targeted assets in any conflict scenario. Every F-22 or F-35 mission in the Indo-Pacific is chained to tankers. Break that chain, and their radius collapses. And that's not criticism, it's physics. They were never built for a battlefield that stretches thousands of miles across hostile waters. But the F-47, it's being shaped for this exact nightmare. Its adaptive cycle engine gives it range and reach, both. Its projected ability to sustain efficient high-speed cruise across long distances means it can operate from deep inside friendly territory without depending on long, exposed refueling corridors. This completely shifts the balance. A 5th-generation jet must fight its way into range, but an F-47 starts the fight already there. And here's the part that stunned planners the most. When paired with CCAs, the F-47's effective presence across the Pacific multiplies, covering areas no 5th-gen patrol pattern can sustain on its own. Suddenly, air dominance stops being a question of tankers, island runways, or vulnerability windows, and more about which side controls the networks that bind crewed aircraft and autonomous wingmen together. We'll get to that part soon. Most comparisons between fighters boil down to which aircraft has the better missile. But this is where 5th-gen jets run into an uncomfortable truth. Their weapons were designed for a battlefield that no longer exists. F-22s and F-35s employ some of the best missiles on Earth like AMRAAM, Sidewinder, SDB, JASSM derivatives, you name it. But even the most advanced 5th-gen weapons rely on propulsion and seeker technology locked behind a plateau the industry has struggled to break for years. The F-47 is not limited by this plateau. It carries weapons designed for speed and reaction windows that 5th-gen jets physically cannot exploit. Analysts expect future systems to integrate hypersonic tactical missiles, smart munitions capable of changing targets mid-flight, long-reach interceptors tailored for extended-range air dominance, and even directed energy or electronic attack payloads intended to disable enemy systems without ever firing a traditional weapon. Some proposals even include AI-supported munitions, able to make autonomous adjustments as the fight unfolds. When word leaked that a 6th-generation aircraft's internal bay could support weapons larger than any 5th-gen could internally carry, analysts assumed it was for longer-range air-to-air engagements. They were half right. The truth is more disruptive. Its weapons are definitely faster, but they're also smarter. They coordinate with CCAs. They share target data. They adapt trajectories. Some even choose priorities dynamically based on battlefield pressure. A 5th-gen missile is a spear. A 6th-gen missile is a hunting pack. So when people ask if 5th-gen stands a chance, it depends. Are they fighting one missile or a system that thinks in real time? Every stealth aircraft has a signature, even if it's small. But 5th-gen stealth has an inherent vulnerability. It focuses on radar frequencies and angles known to be the biggest threats during its design era. Stealth fighters like the F-22 and F-35 are extremely hard to track, but it's not impossible. In open discussions, analysts discuss that the F-47's stealth isn't a reduction. It's a complete transformation. The surface coatings adapt. The geometry diffuses rather than reflects. It has a symmetrical heat signature. The electromagnetic profile shifts depending on which sensors are active in the battle space. This is what Air Force engineers call multispectral low observability. Where 5th-gen tries to disappear from radar, the F-47 is expected to reduce visibility from multiple detection methods. And here's the part most people still don't understand. 5th-generation stealth is passive. 6th-generation stealth is described as dynamic. Some analyst speculation even suggests that future platforms might manipulate radar returns to complicate tracking, though nothing in open sources confirms the existence of such a system. You can upgrade a 5th-gen jet software. You can't upgrade its geometry or the stealth philosophy baked into it. That's why 5th-gen is reaching its limit and why 6th-gen is the next unavoidable leap. A great aircraft doesn't win wars alone. A great industrial machine wins wars. And this is where the F-47's shadow becomes enormous. It's the centerpiece of an industrial ecosystem similar to the digital manufacturing frameworks the U.S. aerospace sector is already developing. Boeing and other major contractors have invested heavily in digital engineering and automated production techniques, allowing engineers to redesign, test, validate, and manufacture new components far faster than traditional paper-era processes ever allowed. 5th-gen jets were built in an era of paper designs and metal prototypes. The F-47 is built in an era of digital twins, automated factories, and artificial intelligence verification. This means one dangerous truth. While adversaries struggle to build a small number of 5th-gen jets, the U.S. can scale F-47 production faster than any previous stealth program. This is industrial dominance, and a 5th-gen adversary trying to keep up isn't just fighting the F-47. They're fighting the entire American manufacturing machine behind it. Which brings us to the question everyone asks. When analysts compare 5th-generation fighters to a system like the F-47, they usually break the discussion into scenarios. But what becomes clear almost immediately is that these scenarios don't exist in isolation anymore. Modern air combat collapses them into a single truth. Whoever controls the information timeline dictates the fight. Take the classic within visual range discussion. On paper, 5th-gen jets retain impressive advantages. The F-22's agility remains unmatched, and the F-35's high alpha authority allows it to point the nose in ways few aircraft can replicate. A next-generation design isn't optimized for slow-speed maneuvering. Its entire purpose lies elsewhere. But contemporary air engagements almost never deteriorate into tight-turn dogfights. The determining factor is who establishes awareness first. And with sixth-generation processing and cooperative sensing, that window opens much earlier for an aircraft like the F-47. The theoretical turning advantage of fifth-gen platforms matters only if the merge happens. Regardless, most projections suggest the merge is becoming increasingly unlikely. Beyond visual range, the contrast becomes even clearer. Fifth-generation jets fuse sensor inputs and present a coherent picture to the pilot. A sixth-generation system is built to interpret the battle space and compress the kill chain into segments measured in fractions of a second. When supported by autonomous wingmen feeding additional data, the decision cycle tightens even further. In BVR engagements, timing is everything, and it's the first place human limits show. The electronic warfare environment pushes this divide further. Even the most advanced fifth-gen cockpit is forced to contend with degraded radar and distorted signals. A sixth-generation design is expected to manage electromagnetic complexity at a fundamentally different level. It maps the spectrum, filters distortions, protects its own networks, and stabilizes the picture automatically. One aircraft tries to survive inside an environment that's collapsing around it. The other is built to operate through that collapse with minimal degradation. That difference changes the entire tactical equation. But the decisive shift appears once the fight expands beyond a single aircraft. A fifth-gen jet enters the battle space as one platform. A sixth-generation jet enters as the center of an integrated team with distributed sensors, electronic warfare partners, autonomous shooters, and reconnaissance nodes. They're all networked through the crewed aircraft. In simulation-based studies of distributed air power, this type of formation consistently produces advantages in detection, engagement geometry, and survivability. The opponent has to respond to a coordinated architecture. The more realistic question that the one planners are now forced to consider is whether a fifth-generation fighter can disengage from a sixth-generation system fast enough to avoid being outpaced. Here's the part that keeps defense analysts awake at night. This isn't a simple technological upgrade, it's a strategic upheaval. For 20 years, fifth-gen jets were the ceiling of global air power. Nations spent billions just to field something comparable. Entire military doctrines were rewritten. But the F-47 changes that entirely. Suddenly, the nations still struggling to field fifth-gen are already outdated. Now the global balance tilts toward whoever can mass-produce a sixth-gen ecosystem. Right now, only one country can do that. Power in the air doesn't always shift through conflict. Sometimes it shifts through capability. And the F-47 is a breakthrough the world wasn't prepared for. And that question we asked earlier. The data and airframe can protect matters more. This is because, simply put, the side that controls information will shape the fight long before airframes ever meet. So, does a fifth-generation fighter stand a chance against the F-47? Maybe in a turning fight, but in every battle space that matters today, it's already outclassed. The next era of air combat is about systems that adapt and act faster than their opponents can react. What do you think? Will fifth-generation jets stay relevant? Or is the age of human-limited fighters ending? Tell us in the comments. And if you want more deep dives into the future of air power, make sure to like this video and subscribe.